Today we are going to start the third topic of Maths 1. Friends, you know the collection of numbers like natural numbers, odd natural numbers, even natural numbers, integers, whole numbers, fractions. There are a lot of collections of numbers. Okay? But now in this topic we are going to discuss about just different collection of some numbers here. See friends, just try to observe here what will happen. Okay, in the collection of the data or numbers, if we observe that numbers and after observing, if you predict or if you can guess the next number, then that collection of numbers is called as sequence. See here. See first, this is 5, 7, 10. Just observe here. This is 14, 19. Yes. Now look here. What is this? Here it is some numbers. But try to observe here. There is something. Observe. 5, 7, 10, 14, 19. Can you predict what will be the next number? Yes? What is here? See here. The difference between first two terms is 2. The difference between second and third is 3. The difference between third and fourth is 4. Just try to observe. Here it is 5. Then definitely the difference between this and the next term is definitely what? 6. That means if we add this 6 to 19, then this will be the next term. Like this we can predict. Then such number of or such collection of numbers is definitely we can say as a sequence. Okay friends, look here. Try to observe here. Okay, I write one more thing. Look here. Here it is 5. Again I will write 7. This is 9. This is 11, 13 and then next. Try to observe here. What is here? Again, same thing is there. Look here. Here it is the difference is what? 2, 2, 2, 2. Yes, then definitely the next one will be the 15, 17. Everywhere the difference is 2. So again we can say this is our sequence. Why? Because we can predict the next terms. Okay? But every time we can predict. Suppose, see here, this is 7, this is 11, this is 12, this is 17, this is 25, and something. Just see here now, what is here? Not always addition only, not always subtraction only. Here, maybe some different parts here there. See here, 7, 11, 12, here, there is some relation. Is there some relation? If there is no relation between two successive terms, then we cannot say it is a sequence. Yes? We cannot say it is a sequence. So this is not a sequence. Just look here. 7, 11, 12, 17. See here, the difference is 4. Yes, 1 only. Here 5. Here it is what? Yes, 8. Like this one. There is something relation. Or sometimes that will be happens only. See here, I write one more thing. See here, 2, 3. Okay? And here, we can say here now this is suppose 5. Okay, now here it is what we can say here it is 1. Okay, that is 2. Yeah. Okay, now maybe here 9. Okay, now here 17 like this. Can you observe what is here? If we predict the next number, then only it is called a sequence. Okay, now can you predict here? 2, 3, see here, the difference is what? 1. Here the difference is what? 2. Here the difference is what? How much? 4. Here the difference is what? 8. What is here? What is this? These are the powers of 2. Look here. This is a matter of here. See here. This is 2 raised to 0. This is 2 raised to 1. 2 raised to 2. 2 raised to 3. That means what? The next one definitely 2 raised to 4. Here we have to add this 16. That means we can take here now 33 like this one. Okay, so all these are the collection of some numbers here. Then we can say all these are what? Sequence. If there is no relation between, then we cannot say it is a sequence. Okay, so when we find the next term, then that collection of numbers we can say it is a sequence. Okay, we'll take some more examples. Just try to observe here. Look friends, here this is 5. Okay, we can take one different one. See here, this is what? Maybe it is 4. Okay, look here, this is what? 3, this is 2, this is 1, and now we are going to predict the numbers. Just try to observe here. What is that? 5, 4. There is some relation, and the same relation is here. Yes? Okay, let's see what will be there. Afterwards, here it is now 5. Okay, we'll take here one more time 5. 5, 5, 5. Just look here. Is there any relation? Yes? That is only try to observe here. See here. 1 upon 5, 1 upon 10, 1 upon 15, 1 upon 20, like this. Just try to observe here. What is that? Look here. There is, the difference is what? 1 here. But actually not the difference 1. Here the difference is minus 1. Okay, take here 4 and 5. The difference is what? 1. But 5 and 4, there is the difference is what? Minus 1. Here also minus 1, minus 1, minus 1. Okay, like this. And then we can write the next term very easily. Here it is, there is nothing the difference. That means only 0 is there. So we can predict the next term is only 5 every time. Yes? Now try to observe. 1 upon 5, 1 upon 10. What is here? Is there any relation? Look here. Here we can predict. See here, 1 upon 5, 1 upon 10, 1 upon 15, 1 upon 20. We can write maybe here the next term is what? 1 upon 25. Yes, 1 upon 30. Means the denominator term is the multiple of 5. That means whenever we can predict the next term, then all these are called as sequences. Okay, now here, when it is sequence, then we can say this is term number 1, first term. This is second term, third term, fourth term, fifth term, sixth term. Like this. And when we can predict, suppose we need here 17th term. Can you find? Yes. Why? Because we can predict the next term. Because there is some relation and that one we observe here. Here what will come here now? Look here. See here. This is 5 ones are 5. This is 5 twos are. Look here. Second term. Here it is first term. Here 5 threes are 15. 5 fours are 20. 5 fives are 25. 5 sixes are 30. Means 5 seventeens are. Amongst 85, that will be the 17th term. Like this we can predict. Here also, you can take every term, any number, 100th term also, here we get here 5. And here also, we can predict. See here, 1, minus 1, here it is 0. Again minus 1, it is 1. Again minus 1, 2. Like this. See here, sorry, here it is minus 1, minus 2. Like this. We can predict here. Yes, all these are the terms of sequences. Okay. Now in this year we are going to discuss if there is some rule in the numbers of collection of numbers in that sequence, that rules sequence only we are going to study. See friends. Now if you observe here, every time the difference we are going to observe. Here also difference. Okay, but not here the difference. Here some difference, that is multiplicating. See here, this is nothing but 5 ones are, here 5 twos are. Look here, every time. Okay? So here, when we multiply here like this 5, 5, 5, then this is also sequence. When difference or addition is some particular number is there, then that is also sequence. Okay? Now here, in this year, we are going to discuss that sequences which are arranged and we can predict the next numbers or nth term. Now it is very important. Then we can take here, this is 17th term. Like suppose here nth term, and that n you can write any number here. If you find that nth term, then this collection of numbers will be the sequence. Okay friends?
Hello friends, see here in activity some sequences are given below. Check whether there is any rule among the terms. Find similarity between two sequences. Okay, now look here. See friends, this is the sum here. Okay, now there are some examples also given to us. We are going to discuss about one by one. Okay friends, look here. See here. Here the important part is what we are going to discuss about that one. See here, this is 1, 4, 7, 10. Okay, now there is some relation. What is relation? See here, 1 plus 3 will get 4. Again plus 3 will get 7. Like this. So what will get here? Yes, 10 plus 3, that means we can write here 13. Is it correct? See here, this is very important. After that, what you can write here now? 13 plus 3. Okay friends, look here, 13 plus 3, here it is 16. So like this we can complete the sequence here. Understand? Very similar here also. 6 plus 6, that is 12 here. 12 plus 6, 18. 18 plus 6, 24. 24 plus 6, yes, what you can write here now? Yes, 24 plus 6, here we can write 30. Okay, now here 30 plus 6, 36. Okay, and so on we can write that one. Now here also the similar part, very important. Look friends, this is really one of the very important part we are going to observing here. See here, what we can write here now. Look here. Here it is 3 plus 0, 3, 3 plus 0, 3, 3 plus 0, 3. Means we can write any time, we can write here 3 only, because the common difference is 0. Therefore, all terms are similar. Okay, now here just a difference. Here we have to multiply by 4, that is 16. 16 into 4, 64. 64 into 4, yes, 4 4s are 16. Yes, carry 1, 4 6 are 24 plus 1, 256. Is it correct? Now again we have to multiply by 4. We'll get here 4 6 are 24. Carry 2, 4 5s are 20 plus 2, 22. Carry 2, 4 2s are 8 plus 2, 10. Like this we can write. Again by 4s up, if we'll multiply, here it is 4096. Like this we can write all terms here. Is it correct? Very similar. Here it is in the next part. Minus 1, here minus 1.5 is there. So minus 1 plus minus 0.5. Okay, again minus 0.5, again minus 0.5. Here it is minus 2.5 plus minus minus. So here we can write here minus 3. Yes, like this we can write all these blank spaces here. If you observe here in the first part, what is that? There is some addition. Okay, the common difference is plus 3 is there. Okay, everywhere. Here the common difference is plus 6 is there. Okay, here common difference is 0. Here the common difference is minus 0.5, minus 0.5, minus 0.5. But only in this fourth part that the common difference is not there. That means first, second, third and fifth. All these are arithmetic progressions. But this, the fourth one, is not a arithmetic progression. This is progression, but it is geometric progression. Why? Because the relation between two consecutive terms, okay, there is same, but the common difference is not there. That is why first, second, third and fifth, all these five are, out of these five, the fourth one is not a arithmetic progression, but remaining all four are arithmetic progressions. Okay. Friends, in the sixth sum, see here, this is the sixth one. What is here? 1 cube, 2 cube, 3 cube and so on. Okay. In this sixth sum, if you observe here, we cannot get anything common difference here, or we cannot get any common multiplication is there. That is why this sixth one is neither arithmetic progression nor geometric progression. Okay, geometric progression means what? See here, the sequence in the next term is obtained by multiplying the previous term by a particular number. Then this type of sequence is called as geometric progression, which is we discussed in fourth sum. Okay, and remaining everywhere by adding a particular number to the previous number. Okay, that particular number may be positive or may be negative. Okay, so such sequence is called as arithmetic progression. Understand, friends? So this here we are going to study only arithmetic progression. Okay.
See friends, we just discussed by activity from that computer screen. Now look here, progression. What is that progression? If there is some relation between two consecutive terms of that sequence is called as progression. That one particular understood here? In that progression, there are actually three types. But in this year, today, that means in this year we are going to discuss about that only this arithmetic progression. Actually, there are two more progressions are there. See first, this is arithmetic progression, geometric progression, and then harmonic progression also. Okay, but only we are going to discuss about this arithmetic progression. Okay, so now you can understand that what is arithmetic progression. Look here, what is that? If the common difference between two consecutive terms is same everywhere, then that progression is called as arithmetic progression. Okay, that means what? Look here, again I will take one example. 7, 13, 19, 25, 31, like this. Look here, this is first term, second term, third term, fourth term, fifth term, and so on. Okay friends, now just try to observe. Common difference means we can take here from second term minus first term. That is difference. We are going to discuss about it. Okay. Now the next one is third term minus second term, fourth term minus third term, fifth term minus fourth term. Like this we are going to. Let's see here. What is T2 minus T1 here? 13 minus 7, that is 6 here. Again 19 minus 13, which is again 6 here. 25 minus 19, again 6 here. 31 minus 25, 6 here. See here, everywhere same. That means that is the common difference. And that common difference is always like T2 minus T1, T3 minus T2. Means what? Suppose you will take here some 7th term minus 6th term. That is D. Every time. That means in general, what we can write here now, that is Tn plus 1 minus Tn is equal to D. This is the common difference. Okay, using this we can write common difference of that arithmetic progression. That is everywhere is same. So called it is arithmetic progression. Understand friends? This is very important one. Sometimes this difference may be positive, may be negative, may be sometimes zero as well. This is very important part of this. Okay friends? See friends, in this sequence, the first term is always said to be a. Okay? See here. And the second term is T2. Okay? That one will come by adding that common difference. Look here. Again, third term, that will come, that common difference. See here, the first term, we can say here, first term, that is a T1 as A, and common difference is a D. Look here, and that common difference we are going to add it to the second term. That will come here A plus D plus D. So what we get here? A plus 2D. Yes. Now after that T4, that will come T3 plus D. Is it correct? Here also, just look here. This is T1 plus D. Means in the previous term we will add that common difference, then we can get that next term. Okay? Means what here? T3 is what? A plus 2D plus D means A plus 3D. Like this are the terms we can get here. From all this discussion, we can predict some general form also. Okay, that one we'll discuss after taking that first exercise. Okay friends, so let's start the first exercise or practice set 3.1. In that we can solve some examples depend all this discussion. First practice set, the first sum is given to us. We are going to identify the given sequences are arithmetic progression or not. What is that sum? See here. Which of the following sequences are AP? Okay, if they are AP, find the common difference. Okay, in that one, first sum 2, 4, 6, 8. See here 2, 4, 6, 8. See first, we are going to identify whether it is AP or not. If AP, then we can find that common difference. So look here, this is T2 minus T1. 4 minus 2, how much? 2 here. T3 minus T2, 6 minus 4, again 2. T4 minus T3, 8 minus 6, 2. Look here, every time we get here 2. So what we can write here? Common difference D is, that is, we can say here same, or you can write here constant also. Okay, therefore the given sequence is AP. And here what is D here? That D is nothing but 2 here. Is same, and that is nothing but 2 you can write here. Like this we can find. Okay, all these are very simple here. Look, I'll take that next one also here. The sequence is given to us 2, 5 by 2, 3, 7 by 2. Like this, they were given to us. Let's check. See here, T2 minus T1, 5 by 2 minus 2. What will come here now? Here nothing is there. So write 1. So 5 is 5, 2 to the 4 upon 2, 1 upon 2. Okay. Now here T3 minus T2, that is 3 minus 5 by 2. Here it is upon 1. Nothing is a denominator. So we can write 1. 2 3s are 6 minus 5 1s are 5 upon 2 1s are 2. So here it is again 1 by 2. Now the next one T4 minus T3, that is 7 by 2 minus 3. So here upon 1 7 minus 2 3s are 6 upon 2. Look here, every time we get here half. What you can write? Therefore, common difference is same. That is nothing but half. Therefore, the given sequence is AP. Therefore, what we can write here now? D. That is a common difference D. Okay, here also you can write common difference. And that is very simply we can find out. Here D is what? That D is nothing but half. Understand, friends? Like this we can solve all this. Now the third sum. That one also very simple here it is. That is minus 10, minus 6, minus 2, minus 2. See here, minus 10, minus 6, minus 2, minus 2. Let's see here whether it is AP or not. Our usual procedure. See how? That is T2 minus T1, which is minus 6 minus minus 10. So minus 6 plus 10, and it is plus 4. Okay, now T3 minus T2, minus 2, minus minus 6. Again here what we get here? Minus 2, minus minus plus 6. This is what flow. Yes, again we can say it is what? Sequence. That is we can say arithmetic progression. Remember, friends, that is very important. If you suppose here the first two times that common difference is same, then we can say directly it is what? Arithmetic progression. That makes very big mistake. So how many terms are there? All terms we are going to check. See here, in the first two it is okay, but let's see the next one. See, what is that? T4 minus T3, that is minus 2 minus minus 2. See here, okay, that comes here 0. Understand? That means always do all the terms. That is very important. Now what we get here? Every time that 4 is not get. Therefore we can write here now common difference is not constant. Therefore given sequence is not an AP or not an arithmetic progression. Okay, understand, friends? So whenever we'll solve the first two times like this, we'll say, then don't try to say this AP. Check whether the next one is also same or not. Okay, friends? Now we'll take that fourth one. What is that fourth one? See here. 0.3, 0.33, 0.333, like this. Okay, now we are going to check whether it is AP or not. Yes, what can you are saying? Whether it is AP or not? Just try to observe here. Yes, let's check. See here. T2 minus T1, 0.33 minus 0.3. See here, this 0.3 is what? May I say 0.30? Yes, because after decimal point, we will write number of so many numbers of 0. No need, not make any mistake here or not any difference here. We can write, we can say. Why? Because there are two digits. So here also we can make the two digits. Yes, then only we can make that difference here. What will we get here now? Here it is 0.03. 3 minus 0, 3. 3 minus 3, 0. 0. That is 0.03. Now what about here? T3 minus T2, that is 0.333 minus 0.33. So here also I will make the same number of digits here. Okay, now what will get here? 3 minus 3, 3 minus 0, 3 is. Now 3 minus 3, 0. 3 minus 3, 0. Now 0 minus 0, that is point afterwards. Here we will write here 0.3. Now look here whether both these are same. No, that means common difference is not constant. Therefore, given sequence is not AP. Yes, friends, like this. You can also solve some examples yourselves. Okay? In the fifth and sixth term. In the fifth sum. 0 minus 4 minus 8 minus 12. Okay? Here also we are going to verify whether it is AP or not. See first. T2 minus T1 minus 4 minus 0. Is it okay? So here minus 4 After that, T3 minus T2, minus 8, minus 4. Look here, this is minus, that's of this one, and this minus 4 of T2. Okay, like this one. Understand? Minus 8 plus 4. So now subtract smaller from greater. Yes, 8 minus 4, 4, and give the greater number sign. Whenever the two terms have different signs, then subtract the smaller one from greater one and give the greater number sign. Okay, now both these are okay. Suppose, just look here friends. Suppose in the first two only the common differences were different. Then no need to find the next one. Okay, because of here both are same, so we are going to take one more. That is what? T4 minus T3, that is minus 12 minus 8, minus 12 minus plus, here it is 8. Again what we get here? Minus 4, because 4 minus 8, 4, and give the greater number sign. Look here, every time we will get the same common difference. So the common difference is constant, that is what you can see here, that is b equal to minus 4. So we can say here, given sequence is arithmetic progression. Therefore, common difference b, which is minus 4. Okay friends, let me take one more, that is sixth one. What is the sixth one? Look here, minus 1 upon 5, minus 1 upon 5, minus 1 upon 5, and so on. Okay, now check whether it is AP or not. Observe here, all terms are same, then the common difference is 0 always. So it is AP always, but try to solve now. See this one, T2 minus T1, what will come here? Minus 1 upon 5, minus 1 upon 5, and it is minus 1 upon 5 plus 1 upon 5. This is 0. Again T3 minus T2, so again the same thing, minus 1 upon 5 minus 1 upon 5, so minus 1 upon 5 plus 1 upon 5, that is 0. Finish. Okay, therefore we can write here now, common difference is constant, that is d is equal to what? 0. Therefore, given sequence is arithmetic progression. Therefore, common difference, that b is what? 0 will get here. Understand friends? Last two sums are there. Seventh one, that is 3 comma 3 plus root 2, 3 plus 2 root 2, and 3 plus 3 root 2, okay, and so on, like this is there. So now we are going to identify whether it is AP or no. Okay friends, see this. As usual, T2 minus T1, T2 is what? 3 plus root 2 minus 3. So this 3 getting cancelled, here it is root 2. Now here T3 minus T2, that is 3 plus 2 root 2 minus, this is binomial, write in bracket. Yes friends, so what do we get here now? Here it is 3 plus 2 root 2 minus 3 minus root 2. This 3 getting cancelled. 2 root 2 minus 1 root 2, it is what? 1 root 2. It is correct. Now one more, that is T4 minus T3, that is 3 plus 3 root 2 minus, again this is binomial, so write in bracket. Now by simplifying, what we can find here now? Just sign changes. Here it is 3 minus, that 3 minus 3 both getting cancelled. 3 root 2 minus 2 root 2, again it is root 2. Now look here, this is root 2, and root 2. Common difference is constant. So we'll write here, common difference is constant. That is what? D is equal to root 2. Therefore, given sequence is arithmetic progression. Therefore, we can write here now that D, which is common difference, D is what? Root 2. See friends, every time I have to observe here. Okay, now the eighth one, which is the last of this question. What is that? 127, 132, 137 and so on. Let's see whether it is AP or no. See here, T2 minus T1, 132 minus 127, how much? 5. Okay, and T3 minus T2, 137 minus 132, again it is 5, therefore common difference is constant, that is D equal to 5. Is it correct? Therefore, the given sequence, yes, the given sequence is AP. Therefore, common difference is 5. Like this, we can solve the sums. Okay friends, understand? This is the way to verify whether the given sequence is AP or no. Okay. In the question number 2, what is that? We are going to write that AP, whose first term and common difference D is given to us. Okay. By using these two, we are going to write that AP. Okay. Now see, in that one, the first one is A is equal to the given to us 10 and B equal to 5. Now we are going to form that A. See first. What is that? T1 means A. Means what? That 10 is given to us. Now, just try to observe that T2 is nothing but T1 plus D. Understand? So here T1 means what? 10 plus D is what? 5. Here it is 50. Okay. Now T3, that is T2 plus D. What about that T2? 15 plus D, 5. Here it is what? 20. Therefore we can write, what is that? 10, 15, 20, dot 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 is required. Arithmetic progression. Like this we can form that arithmetic progression. Okay friends, see one more when given to us. A is equal to what? Here minus 3 and B equal to 0. See how simple it is. T1 means A is equal to minus 3. And what about T2? That is T2 means what? T1 plus, we can write here D. Yes. Now T1 is minus 3 and what about D? It is 0. So we get here minus 3. Okay, now one more. T3, that is T2 plus D. T2 minus 3 plus D is 0. Again minus 3. Therefore what we can write here? Minus 3, minus 3, minus 3, dot 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 is, yes, required arithmetic progression. Yes, one more. See here, A is equal to minus 7, D is equal to half. A is equal to minus 7, D is equal to half. Okay, see first. T1, that is A is equal to minus 7, T2, T1 plus D, T1 minus 7, D half. Look friends, now minus 7 plus, minus plus, we have to subtract. Okay, now here, just try to observe here. Here nothing is there, that is 1. Just try to simplify. What do you get here? 7 2s are, yes, 7 2s are 14. And here, plus 1 1s are 1 upon 2. How much? Minus 13 by 2. Is it okay? Now one more. T3, that is T2 plus D. T2 minus 13 by 2. And what about D? That is plus half. Always plus. Okay, there is a formula. Plus D. But that D may be positive or negative. But D we have to add only. Okay, here it is. Right, 2 ones only. Minus 3 plus 1. So how much we get here? Minus 12 upon 2. There it is minus 6. Therefore, what is that our AP? Look here. Minus 7, minus 13 by 2, minus 6. Okay, dot 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 is required AP. Is it correct? Like this we can solve. Okay friends, next sums. See here, the fourth one, we already took the 3 sums. Here it is. A is equal to minus 125. 1.25 And what about D here? D is 3 here. From this information, we are going to find that A here. Okay? See. What about T1? That is nothing but A, which is 1.25. Okay, friends? Now, what about T2? T1 plus D. This is minus 125 plus D. D means 3. Yes? How much you get here now? Look here. This difference should be, you can make some mistakes here. Look here. This is because of plus. It is a greater number. So, subtract greater, smaller one from greater. So 3 right here. Here it is minus 1.25. Here we have to write like this. Okay, friends. Now 10 minus 5, it is 5, carry 1. 10 minus 3, it is 7, carry 1. 3 minus 2, it is 1. And give the greater number sign. That is plus. So plus 1.75. Like this we can solve. Okay, afterwards. One more. That is T3 is equal to T2 plus D. T3, which is just will find this is 1.75. And what about D? Which is 3, and here both are positive. That means 3 plus 1, integer and integer we have to add, and then a decimal part. So 0.75, 3 plus 1, 4. Therefore, here these are that terms of sequence. 1 minus 1.25, comma 1.75, comma 4.75, dot is required arithmetic progression. Okay, friends. Now similarly here there are two more sums are there. See here, that are what? A is equal to 6 and D is equal to what? Minus 3. Look here. What we can get here now? T1, that is A, which is 6. T2, that is T1 plus D. 6 plus minus 3. Remember, very important. 6 minus 3, which is 3. Now what about T3? That is T2 plus D, that is T2 3 plus minus 3. Here it is minus, that is 3 means here it is 0. Therefore 6, 3, 0, dot. You can find some more also, but 3 terms sufficient. That okay is required arithmetic progression. Okay, friends. Now the last one, here it is 120. Sorry, what? 6 is equal to minus 19. A is equal to minus 19. D is equal to minus 4. Okay. Now look here. That is T1 is equal to A, which is minus 19. T2, that is T1 plus D. T1 minus 19 plus minus 4. So minus 19 minus 4, here it is minus 23. And T3, that is T2 plus D. T2 minus 23 plus minus 4. So minus 23 minus 4, here it is minus 27. Therefore the terms are minus 19, minus 23, minus 27 and so on is required arithmetic progression. Okay, friends, like this we can solve. Friends, in the question number 3, which is the last question of this exercise, that is practice set. See here, what is the question? They are given to us some arithmetic progressions, and from that arithmetic progressions we are going to find the first term and their common difference, which is so simple here. Okay, we'll take that first one. See here, 5, 1, minus 3, minus 7. 5, 1, minus 3, minus 7. Friends, already they are given to us is an AP. Okay, is and AP. See, always the first term, that is nothing but that A, which is 5. Not always 5, but first term is this one. Now common difference, which is D, that is you can say that T2 minus T1. It is sufficient. Or you may take T3 minus T2 or T4 minus T3. But everywhere, because of it is AP, everywhere is that common difference is constant. So T2, that is 1 minus 5. How much? Minus 4. Therefore, A is equal to 5 and D is equal to minus 4. Like this we can solve. Yes, that is enough. Okay, we'll take the second one. What is the second one? Here it is 0.6, 0.9, 1.2, 1.5. 0.6, 0.9, 1.2, 1.5. Okay, is an arithmetic progression. Here also, the first term is A, that is 0.6. And what about common difference? CD, that is you can take here T2 minus T1. T2, 0.9 minus 0.6. How much? That is 0.3. Therefore, first term A, which is 0.6, and common difference B, which is 0.3. See here, how simple all these are. Yes, one more. That is 127, 135. 127, 135. Here it is 143 and 151. These are some terms are given of an AP. It is an AP. Okay. Now what is that? T1, which is A, that is 127. What about common difference? That is T2 minus T1. T2, 135 minus 127. I think that common difference is 8. So A is equal to 127 and B is equal to 8. Like this we can solve. Yes, now one more remains, that is fourth one. Is look here. 1 upon 4, 3 upon 4, 5 upon 4, 7 upon 4. See here, 1 upon 4, 3 upon 4, 5 upon 4, 7 upon 4, like this they were given to us. Okay, now is an AP. Okay, is an AP. See here, that first term which is A, that is 1 upon 4. Okay, now what about that common difference? That is T2 minus T1. What is T2? 3 upon 4 minus 1 upon 4. That common difference, denominator is 4. Same. So 3 minus 1. How much? And it is 2 upon 4. This is after division 1 upon 2. Like this we can get here. First term which is common. First term is this T1. That is 1 upon 4. Okay. And the common difference is 1 upon 2. Like this we can solve all these sums. Actually, some students, this 3.1 practice set, which is just for our practice purpose only of whole arithmetic progression, in which we can identify whether it is AP or no. How we can find common difference? How we can find first term? Like this. Okay. After getting all this information, the next part is very, very important. Okay. We'll stop here. In this practice set, we'll discuss about all this one. Now the next part we'll discuss in the next class. Okay friends?